Hey guys, welcome back. Today we're going to be studying rotations. Our learning target again is to define, understand, and apply rigid motion transformations. We're going to do that by first defining rotation, identifying angles of rotation using a protractor, rotating the figures using patty paper, and then we're also going to perform arrow notation in order to help us rotate these figures. So let's take a look at the main idea. It says a rotation is a rigid motion that turns a figure about a fixed point called the center of rotation. Now, for our purposes, our center of rotation is always going to be at the origin, but just know that you can actually rotate about a point that is not the origin. So for now, just know that whenever we rotate, it's going to be around 0, 0. The angle of rotation is the number of degrees the figure rotates. A positive angle of rotation turns the figure counterclockwise. Okay, so as shown in this diagram here, the arrow is pointing counterclockwise. That's because angles are going to open up from the x-axis, and they want you to start opening the angle in the first quadrant, then go into the second quadrant, the third, and then the fourth. That's why counterclockwise is how we're going to be rotating angles. You can rotate things clockwise, but if it's not specified, you have to assume that you're going to be rotating it counterclockwise. So let's take a look at the first example. This one, all we're doing is really just recognizing which one is a rotation. Now, rotations can be really hard on your brain. It's hard to identify them sometimes. So what I like to do is eliminate choices by identifying other movements. So this one, the one on the end, this one is a translation because it's just sliding. Okay, all the points are moved the same amount. Okay, so that was 4 units, this was 4 units, this is 4 units. They all moved 4 units down. Okay, the middle one is a mirror image, so that is a reflection. Okay, I can tell because if you were to flip over the x-axis, B is 1 unit away and B prime is 1 unit away. C is 2 units away and C prime is 2 units away. A is 3 units away and A prime is 3 units away. That brings us to, okay, so the second one and the third one, those are not rotations. That brings us to the first one. If you notice, if you actually turn your screen, you can actually see, and if you turn it, easiest way would be clockwise. If you turned it this way, B would land on top of B prime, A would land on top of A prime, and C would end up on top of C prime. You could also go this way. It'll just take a little further for you to turn it. So the first one is our rotation. So go ahead and give this a try. I just want you to identify which one of these is a rotation. Alright, so on this next example, we're going to be using our protractors. Say you have a point P and P prime on the coordinate plane, and you want to know, didn't mean to get rid of it, and you want to know what the angle of rotation is around center O, or the origin. Okay, for us, I'm going to mark this. This is most likely going to be the origin. So I want to know, what is the angle of rotation from here to there? Well, the first thing we're going to have to do is draw a line from the origin to point P, through point P actually, and another line through P prime. So take the straight edge part of the protractor that you've been given and draw this really straight line from the angle of rotation through point P and also through P prime, creating that angle. Now, I don't have a ruler in this video, but you need to use the straight edge side of the protractor to actually create these lines. And then what you're going to do is you're going to put the protractor on top of it. Notice how when we put the protractor on top, we put the hole of the protractor, or sometimes it'll have just like a little T on the actual center of rotation. And then you also want to make sure that one of the lines is lined up with the bottom line of the protractor. So now you can actually see the angle opening up this way. Now, whatever line you put your protractor on top of, like here, that's going to be where your 0 mark is. Notice there are 2 sets of numbers on your protractor. Wherever you line the bottom line up, start your eyes on 0. So we're actually going to be using these inner numbers because of where I lined up my protractor. So when you look at the inside numbers, you can tell now that the line that we connected through P prime is at about, I would say, 135 degrees. That's how you would read that protractor, because it's halfway between 140 and 130. Okay, so this would be approximately 135 degrees. So let's give this another try in an example. I've put steps on your guided notes. I'm not going to read through all of these steps. I really just went through it already, but if you forget what you're supposed to do with your protractor, just look at these steps. So now let's try it in an example. So the first thing we want to do, it says, what is the angle of rotation about the origin, okay, so the 0, 0, that maps ABC onto A prime, B prime, C prime. So again, you want to draw 2 straight lines, use the straight edge side of your protractor through any 2 of the original point and then its corresponding point. So I'm just going to draw a line through A, because A is pretty easy to draw a line through right now. So I'm going to draw, and again, you want to use the straight edge part of your protractor. I'm going to draw a line through A, and I'm going to draw a line through A prime, creating this angle. Okay, and I want to know what that angle of rotation is. So when I put my protractor on top, it's going to look something like that. Again, I lined up one of the sides of the angle that I drew with the flat line of the protractor, and I made sure that the little hole or the T, little crisscross thing on the protractor was lined up with the center of rotation. So now, since I lined up over here, I'm going to use the inner numbers again, and I'm going to read where the line went through, which I can see it's crossing right about there, which is about 90 degrees. Okay, so I would say that the angle of rotation of this figure was 90 degrees to map ABC onto A prime, B prime, C prime. You only really have to measure one of the vertices. You don't have to measure all of the vertices. So let's have you guys give this a try in your U-Try. Use your protractor, line up the center, and then line up the bottom of the protractor with one of the lines that you see. What is the angle of rotation from JKO to J prime, K prime, O prime? All right, so in this last example, here's a little intro for you. You're not going to want to use a protractor every single time you want to actually rotate a figure. You should be able to rotate your figure using something called patty paper, which it's kind of going to look like wax paper. It's going to be see-through. And on the next slide, I will show you a clip of someone rotating a figure using patty paper. Okay, but what I would like you guys to do is just take a look at the arrow notation of these points. This is a 270 degree rotation. Now, if you notice, the points, like if we specifically look at A, you have the digits 4 and 6. The X value is -4, the Y value is 6. Now, if you notice A prime, it looks like the 4 and the 6 just switched spots. Okay, so a little note for you guys, if you are rotating a multiple of 90, there's going to be a pattern, okay, that you don't even need to use patty paper with. And I'm going to have you guys write that down just in case you want to double check after you rotate using patty paper, or if you don't want to use patty paper at all and you find this method to be even easier. So my note will be that if you rotate 90 degrees or 270 degrees, all you have to do is switch X and Y, and then you need to think about the signs as far as what quadrant it is. Okay, meaning you have the first quadrant, you have the second quadrant, you have the third quadrant, and the fourth quadrant. In the first quadrant, it's positive, positive. In the second quadrant, it's negative, positive. Third quadrant is negative, negative. And fourth quadrant is positive, negative. So if you notice, all of the points of the original figure, which is over here, all of the points in the original figure started negative, positive. Okay, I see negative, positive, negative, positive, negative, positive. Okay, so if I just take the positive version of 4 and 6 and I switch their spots, and then I think about what quadrant it's going to land in, 270 degrees, that's 3 turns of 90. Okay, because 270 divided by 90 is 3. So it's kind of like it hops from the second quadrant to the third quadrant to the fourth quadrant, back up to the first quadrant. That's 1, 2, 3 turns of 90. Okay, that would be 270 degrees, which the first quadrant is all positive, positive. That's why A prime is positive, positive. Positive 6, positive 4. Positive 1, positive 2. Positive 4, and positive 1. Okay, so that method you don't even need patty paper in order to do. You just need to write down your arrow notation and then plot the points. But patty paper can be a little easier for some. So in this example, I'm going to show you a video of someone actually rotating ABCD using patty paper.
Okay, in this instructional video, I want to show you how you use patty paper to create a visual for performing a rotation. And in this example, I have given you a little bit more of a complicated figure just to show you how we're going to track coordinates or points A, B, C, and D as it rotates around the origin. So what I'm going to do with my patty paper, and you can reuse this over and over again, this is a clean sheet. So what I'm going to do with this is I'm going to mark the origin, and I'm going to give myself the crosshairs of the X and Y, because that way, see how it looks when you move it up, that way as I turn it I can see where I'm going. So I'm just going to start with that and give myself, you can draw out the whole rectangle here, but I'm going to give myself at least the points, and I'm going to label my points. I can see them through the tracing paper. I'm going to label my points so that when I rotate it, let's make sure it didn't move, so that when I rotate it, I can see how they change. Now, I'm going to rotate this 90 degrees, 180, and 270 degrees. And notice that I don't have to say counterclockwise or about the origin, because that's implied. So let's rotate 90 degrees. So watch right here as I rotate around the origin. And you can see the crosshairs that I have change. So you can make these bigger if you'd like to. But you're going to rotate that 90 degrees. And now I have my new coordinates, which are going to be, I'm just going to lift my paper up. This is now D prime, and I have C prime over here. And B prime is 2 units away, so I can move that out. And A prime is going to be right there. And it's not intuitive, really, how this is going to rotate 90 degrees. So the patty paper really helps. Of course, the last thing to do here is to use your straight edge and connect your point. And that
Go ahead and give this process a try in your U-Try. Please try this on your own first, and if you're having any trouble, please make sure you raise your hand and ask for some help. Now that you have studied rotations, I want to have a little closure problem for you guys. I want you to plot the points W, X, Y, and Z down on the grid, and then the vertices of this image is a parallelogram, which they give you the coordinates of W prime, X prime, Y prime, and Z prime. What is the angle of rotation? You can use your protractor or you can try to use your patty paper. Enter your answer in the box to the right. Please don't include spaces and you don't need to include the word degrees. Just type the number that you see for your angle. All right, that about wraps up our lesson today. We defined rotation in the key concept. We identified angles of rotation using a protractor. That was in example 2. Okay, and actually we did define the rotation in example 1 as well. We were able to identify it. And we rotated figures using patty paper in example 3. We're going to practice more of the performance of arrow notation and actually rotating these figures more tomorrow. So go ahead and start on your Google Form homework. Thank you very much. Have a great day.